Introduction to SDLC or Basics of SDLC. In this video, we are going to see about Introduction to SDLC or Basics of SDLC. The System Development Lifecycle, that is SDLC, is a structured sequence of phases for implementing an information system. The System Development Lifecycle is also known as Application Development Lifecycle. It is a term used in system engineering and software engineering to describe a process for planning, creating, testing, and deploying an information system. The System Development Lifecycle concept applies to a range of hardware and software configurations. An organization may feel the need for a system due to a variety of reasons. Problem faced by person performing a function. There may be a need to improve operations. Customers may demand a better level of service organization, a different type of service which requires a system. The corporate image may need to be enhanced by using systems. It may be felt that they are necessary to enable to cope up with increased volumes and organized expansions of operations. Requirement System Analysis. In this video, we are going to see about Requirement System Analysis. System analysis is a process of collecting factual data, understand the processes involved, identifying the problems, and recommending feasible suggestions for improving the system functioning. The analysis phase is a detailed study of the existing system, its features and problems. Analysis requires data collection from a variety of sources. Various tools like questionnaires, forms, interviews, study of existing documents, records, and brochures are used for this purpose. System analysis involves studying the business processes, gathering operational data, understand the information flow, finding out bottlenecks, and evolving solutions for overcoming the weaknesses of the system so as to achieve the organizational goals. In analysis phase, the system boundaries are clearly determined as it interfaces with other systems. System analysis also includes subdividing of complex processes involving the entire system, identification of data store, and manual processes. The major objectives of system analysis are to find answers for each business process. What is being done? How is it being done? Who is doing it? When is he doing it? Why is it being done? How can it be improved? System analysis is more of a thinking process and involves the creative skills of the system analyst. The focus in this phase is to understand all the relevant facts and deriving what needs to be done to solve the problem at hand. System analysis attempts to give birth to a new efficient system that satisfies the current needs of the user and has scope for future growth within the organizational constraints. The result of this process is a detailed logical model of the system along with pertinent data. The focus of this resulting document is on what the system is to do, how it is to be done is the thrust of the next phase. System analysis is an iterative process that continues until a preferred and acceptable solution emerges. System design. In this video, we are going to see about system design. System design is a phase when the what the system is to do is converted into how the system shall do it. System design is composed of the following: high-level design, detailed low-level design, inputs, outputs, files or databases, procedures, user requirements. Based on the user requirements and the detailed analysis of a new system, the new system must be designed. Design. Design starts with identification of alternate technical solutions, selecting the most suitable solution and detailing it out. This is a phase of system designing. It is the most crucial phase in the development of a system. Logical design. The logical design produced during the analysis is turned into a physical design, a detailed description of what is needed to solve original problem. In the design stage, the programming language and the hardware and software platform in which the new system will run are also decided. A cost-benefit analysis is also performed at this stage. Output of the detailed design. The output of the detailed design is used to program the system and test it out. Output design. Data structure, control process, equipment source, workload and limitation of the system, interface, documentation, training, procedures of using the system, taking backups and staffing requirement are decided at this stage. The illustration of system design. Software acquisition, make or buy. In this video, we are going to see about software acquisition, make or buy. The work performed by a computer system depends to a large extent on the software resources available in an organization. Software is the brain, heart, and soul of any computer system. Software needs can be defined in terms of functions of the software. It performs three basic functions in relation to IT infrastructure. It manages the IT resources in an organization. It offers tools for utilization of IT infrastructure, and it acts as an interface between the information and the users. Accordingly, software needs can be defined under three broad categories. System software. System software manages the hardware resources such as primary and secondary memory, output devices such as printers, etc. Operating system. Operating system is an integrated set of programs which acts as an intermediary between the user and the computer hardware. Operating system controls the input-output operations, performs the system scheduling tasks, takes care of system interruptions, monitors system status, and gives appropriate messages to different hardware and users. The popular operating systems are MS-DOS, Unix, Windows 95, etc. Translation software. Translation software translates a program written in programming languages such as COBOL, Fortran, C++, and Pascal into machine-recognizable instructions. Application software. Application software offers tools for satisfying the user's needs for information. Application software is the collection of programs that actually process data to generate information from various applications. Interaction query software. This software is also called end-user languages and 4GLs, and they enable the user to develop limited applications for their use without much of technical expertise. The interaction or query software serves as a language of interaction between users and programmers on one hand, and a stock of information stored on computer system on the other. Planning for software acquisition involves two basic decisions: make or buy decision and selection of specific software. The make or buy decision of software is complicated due to the variety of decision situations that may prevail among different elements of the software portfolio. Ready-made application packages are available in the market for many business functions, including accounting, for example, payroll and inventory control, general ledger, financial planning, and numerous other applications. Advantages of ready-made application software: low cost, high quality, low risk. Disadvantages of ready-made application software: the ready-made application software package may not fit into the specific requirements of the application. Software evaluation and selection or development. In this video, we are going to see about software evaluation and selection or development. Evaluation and synthesis. Problem evaluation and solution synthesis are the next major area of effort for analysis. The analyst must evaluate the flow and content of information, then define and expand all software functions, understand software behavior in the context of event of the effort system, establish system interface characteristics, and uncover design constraints. Each of these tasks serves to describe the problem so that the overall approach or solution may be synthesized. Evaluating the problems and desired information with the input and output, and the analyst begins to synthesize one or more solutions. Throughout the evaluation and solution synthesis, the analyst's primary focus is on what or how does the system produce data and consume, what functions must the system perform, what interfaces are defined, and what constraints are applied. RAD, Rapid Application Development. In this video, we are going to see about Rapid Application Development (RAD). Rapid Application Development (RAD) is a software development methodology that uses minimal planning in favor of rapid prototyping. A prototype is a working model that is functionally equivalent to a component of the product. RAD model design. RAD model distributes the analysis, design, build, and test phases into a series of short, iterative development cycles. Following are the phases of RAD model: business modeling, data modeling, process modeling, application generation, testing and turnover. Prototype. In this video, we are going to see about prototype. Prototyping is a means that is being increasingly used to gather requirement specifications from users. Prototyping is a means of exploring ideas before you invest in them. Prototyping allows system analysts quickly show users the basic requirement into a working version of the desired information system. After viewing and testing the prototype, the users usually adjust existing requirements to new ones. The goal of using prototyping is to support requirement determination, is to develop concrete specification for the ultimate system, not to build the ultimate system from prototyping. Prototyping is most useful for requirements determination when user requirements are not clear or well understood. Few users and other stakeholders who are involved with the system have possible designs which are complex and require concrete form to fully evaluate. Prototyping is using when there is a communication problem between the users and the analysts. When adopting prototyping, analysts should concern about the potential problems about this requirements determination method, such as informal documentation. A survey of MFIS managers in Fortune 1000 firms suggests that there are 4 prototyping methodologies in use today which supplement the traditional systems development lifecycle. They are as follows. Illustrative. It produces only mock-ups of reports and screens. Simulated. It simulates some system functions but does not use real data or a database. Functional. It performs some actual system functions and uses real data and or a database. Evolutionary. It produces models that become a part of the final operational system. Another way that prototypes are classified is by the fidelity of the prototype or the degree to which the prototype represents the appearance and interaction of the system. The types are given as follows. A low-fidelity prototype is one that is quickly constructed to depict concepts, design alternatives, and screen layouts. Medium-fidelity prototypes partially simulate the system interaction and functionality. High-fidelity prototypes are fully interactive, simulating much of the functionality in the final product. Prototyping is found useful in a number of situations, like when the user is unable to articulate the requirements, user cannot visualize the system he wants, especially new users who have an idea of what a system could look like. When the environment is new and not fully understood by the user or the analyst, where the requirements are expected to evolve. For example, a decision support system where the user wants to have an idea of what the system can do, come up with more requirements. When the uncertainty is high, the representation of prototype model. Hardware evaluation and selection. In this video, we are going to see about hardware evaluation and selection. The systems come with hardware, software, and support. Today, selecting a system is a serious and time-consuming business. There are several factors to consider prior to system selection. Define the system capabilities that make sense for business. Computers have proven valuable to business in the following areas: cost reduction, cost avoidance, improved service, improved profit. Specify the magnitude of the problem, that is, clarify whether selections consist of a few peripherals or major decisions concerning the mainframes. Assess the competence of the in-house staff. This involves determining the expertise needed in areas such as telecommunications and database design. Acquiring a computer often results in securing temporary help for conversion. Planning for this help is extremely important. Develop a schedule for the selection process. Maintaining a schedule helps keep the project under control. Major phases in selection. The selection process should be viewed as a project, and a project team should be organized with management support. In larger projects, the team includes one or more user representatives, an analyst, and EDP auditor, and a consultant. Several steps make up the selection process: requirement analysis, system specifications, request for proposal RFP, evaluation and validation, vendor selection, evaluation process. There are three processes for evaluating hardware and software: benchmark program. Benchmark program is a sample program for evaluating different computers and their software. It is necessary because computers often use the same instructions, words of memory, or machine cycle to solve a problem. Experience of other users. Benchmarking only validates vendors' claims. Experience of other users with the same system software is essential. Product reference manuals. These evaluate a system's capability. These reports elaborate on computer products, services, and prices. Evaluation of proposals. After all proposals are evaluated, the final vendor is selected using any of the three methods. Ad hoc refers to the user's inclination to favor one vendor over others. Scoring. In this method, the characteristics of each system are listed and score is given in relation to the maximum point rating. Then each proposal is rated accordingly to its characteristics. Cost value approach. In this method, a dollar credit method is applied to the proposal that meets the user's desirable characteristics. Performance evaluation. Hardware selection requires an analysis on the following criteria: system availability, compatibility, cost performance, uptime, support, usability. Systems operations and organization of systems resources. In this video, we are going to see about systems operations and organization of system resources. The resources available for IT system operations and constraints that confine operation in an organization. It including hardware, software, operations team skills and knowledge, and the organization and management of operation functions. Selection of resources for development. The use of IT resources to operate IT systems. The development resource and constraints that affect IT system development. Within an organization, it includes development methodologies profile, development tools such as case tools, system development team skills and knowledge, and the organization and management of operations functions. The organization resource and constraints that influence IT systems. Organization environment includes organizational culture, goals, tasks, structure and management philosophy and style. The resources and constraints that affect IT system from sources outside the organization that are social, political, cultural, and economic issues. Systems documentation. In this video, we are going to see about systems documentation. Documentation is one of the systems which is used to communicate, instruct, and record the information for any reference or operational purpose. They are very useful for representing the formal flow of the present system. With the help of documentation, it is very easy to track the flow of system's progress, and working of the system can be explained very easily. It helps to provide the clear description of the work done so far. It is essential that the documents prepared must be updated on a regular basis. This will help to trace the progress of work easily. With appropriate and good documentation, it is very easy to understand how aspects of the system will work for the company where the system is to be installed. It also helps to understand the type of data which will be inputted in the system and how the output can be produced. After the system is installed, and if in case the system is not working properly, it will be very easy for the administrator to understand the flow of data in the system with documentation, which will help he or she to correct the flaws and get the system working in no time. Uses of documentation. It facilitates effective communication regarding the system between the technical and the non-technical users. It is very useful in training new users. With a good documentation, new users can easily get acquainted with the flow of the systems. Operation manuals. In this video, we are going to see about operations manuals. A user's guide, also commonly known as an operational manual, is technical communication document intended to give assistance to people using a particular system. It is usually written by a technical writer, although user guides are written by programmers, product or project managers, or other technical staff, particularly in smaller companies. Operation manuals are most commonly associated with electronic goods, computer hardware, and software. The section of an operation manual after include the following: a cover page, a title page and copyright page, a preface containing details of related documents and information on how to navigate the user guide, a contents page, a guide on how to use at least the main functions of the system, a troubleshooting section detailing possible errors or problems that may occur along with how to fix them, a FAQ, frequently asked questions, where to find further help and contact details, a glossary, and for larger documents an index. User manual. In this video, we are going to see about user manual. The user manual is prepared reflexively because it is an item that must accompany every system. There are times when a user manual is discretionary. The important point is that the manual should be prepared only if it will serve the user. A manual is necessary when the user is geographically removed from the project team or when she or he cannot attend all the training sessions. If the user requests a manual, then one must be prepared. It should discuss, among the other things, the functions available to the user and what each can do, how they are executed, and how diagnostic messages should be handled. The manual should be well organized and indexed for quick reference. Graphics, pictures, and line drawings enhance the teaching value of the material. Training and end-user computing. In this video, we are going to see about training and end-user computing. Training for users is based primarily on major system functions and the users need to access them. For example, if a system manages a law firm's records, the user must be trained in record management functions, creating and retrieving records, changing and deleting entries, and so on. In addition, users must navigate through the records to access particular ones. If information is need to be protected with a password or against accidental deletion, users learn special protection functions. At the same time, users need not be aware of the system's internal operation. They can sort a set of records without knowledge of whether the sort is a shell sort, a bubble sort, or a quick sort. A user accessing the system may not need to know who else is accessing it at the same time or in which disk the requested information is being stored. Because these are support functions rather than primary ones, only the operator is concerned with them. User training introduces the primary functions so that users understand what the functions are and how to perform them. Training relates how the functions are performed now with the existing system to how they will be performed later with a new one. The similar but subtle differences between old and new activities can impede learning, so we must design our training to take this difficulty into account. End-user computing. The widespread use of personal computers and computer-based workstations has brought with it the age of end-user computing. End-user computing is a generic term for any information processing activity performed by direct end users who actually use terminals or microcomputers to access data and programs. The manager as end user may be provided with powerful software like DBMS for accessing data, developing models, and performing information processing directly. This has brought computing directly under the control of the end users and eliminates their dependence on the information systems specialist and the rigidities of pre-designed procedures. They may now make ad hoc queries of information and analyze it in various ways. They may write programs or may often use ready-made programs stored in the computer using the computing power of a local PC or the mainframe to which it is connected. System testing. In this video, we are going to see about system testing. Testing is a process to check the software or system whether it gives the required output or not on given set of data. In other terms, we can say that it is a process to fail particular system because in testing, we prepare all possible set of data and apply to the system to check it gives expected output. So system must give expected output or must be properly shut down in abnormal cases. Testing can be categorized into black box testing, white box testing. Black box testing. It emphasizes on input data and expected output of the system. It does not include the process from which the inputted data converts into required output such as internal control conditions, loop statements, etc. White box testing. In white box testing, we emphasize on each and every step from which data moves and converts into required output such as control statement, repetitions, constraints, comparisons, etc. Assessment. In this video, we are going to see about assessment. A software system process assessment is an appraisal or review performed by a trained team of software professionals. Its purpose is to determine the current state of an organization's software process, to identify the highest priority process issues, and to facilitate improvement actions. Assessment principle. A good assessment requires a competent team, sound leadership, and a cooperative organization. Because of the human-intensive nature of the software process, however, there are some special considerations. The need for a process model as a basis for the assessment, the requirement for confidentiality, senior management involvement, attitude and teamwork, and action orientation. Security assessment, requirement study and situation analysis, security policy creation and update, document review, risk identification, vulnerability scan, data analysis, report and briefing. Security assessment report should include the following information: introduction or background information, executive and management summary, assessment scope and objectives, assumptions and limitations, methods and assessment tools used, current environment or system description with network diagrams if any, system requirements, Summary of findings and recommendations. The general control review result. The vulnerability test results. Risk assessment results including identified assets, threats, vulnerabilities, impact and likelihood assessment, and the risk results analysis. Recommended safeguards. Risk assessment. Organization must periodically assess the risk to organizational operations including mission, function, image or reputation, organizational assets and individuals resulting from the operation of organizational information systems and the associated processing, storage, transmission of organizational information. Identify hazards, that is, anything that may cause harm. Decide who may be harmed and how. Assess the risks and take action. Make a record of the findings. Review the risk assessment. Conversion in startup. In this video, we are going to see about conversion in startup. Conversion means changing from one system to another, that is, changing from the old system to the new system. When the new system is fully tested and proved, conversion from old to new is possible. Activities involved in conversion plan are given as follows. Converting the files and database from the old system to the new system. User training to all members of the organization in which the new system is deployed. Converting forms. This may involve discarding of old forms, manual registers, etc. Converting physical activities, for example, replacing old input or output devices with a new one. Converting administrative procedure, that is, defining role of different members, assigning responsibilities to them as per the requirements of the new system. Checking the result of the new system with the data, etc. Conversion methods. In this video, we are going to see about the conversion methods. There are 4 methods of conversion. Each method has its own advantage and disadvantage. No single method is suitable for converting all types of system. The following are the 4 conversion methods: parallel system, direct cutover, pilot approach, phase-in method. Parallel system. In this method, the old and new systems are run concurrently for same period. Its main attraction is that the old system is kept alive and it is operational unit. The new system has been proved for at least one system cycle. It allows the result of the new system to be compared with the old system before acceptance by the user, thereby promoting user acceptance. Advantages of parallel system. This method is very safe because if problem arises in using the new system, the organization can fall back to the new system without loss of time. Disadvantages of parallel system. Its main disadvantage is the extra cost. The difficulty is the impartability of user staff having to carry out the different clerical operations for two systems in the time available for one. Direct cutover. Direct cutover is the complete replacement of the old system by the new system. This method is introduced when there are insufficient similarities between the old and the new system. It is best to introduce a new system directly at a time when work is slack. This method is potentially less expensive but more risky. Thus, direct cutover is an effective method in so far so it minimizes the duplication of work but demand careful planning, testing and operational details of its complete success. Advantages of direct cutover. It is an efficient and fastest method, least expensive. Disadvantages of direct cutover. Require careful and advanced planning. It is very risky. It causes serious problems when the new system fails. Stop entire organization functions. Pilot approach. In this method, a working version of the system is implemented in one part of the organization, such as department knows that they are piloting a new system. Changes may be made to improve the system. When the system is considered beneficial, complete and fully functional, it can be implemented throughout the year by cutover method or by phase-in method. Advantages of pilot run approach. It has the advantages of providing providing ground for full implementation. Phase-in method. Phase-in method is used when it is not possible to install a system throughout an organization all at once. In this method, the new system is implemented in many phases. The conversion of files, training of personnel, or arrival of equipment may also force the staging of the implementation over a period of time. The representation of the phase-in method. There is no danger of total breakdown. This method reduces the risk inherent in a direct changeover of the whole system. Disadvantages of phase-in method. It cannot be used in situations where the time period provided for conversion is very less. It creates a problem in controlling the select parts of the old and the new system. Hardware contracts and software licenses. In this video, we are going to see about hardware contracts and software licenses. Hardware contract. Contracts between an organization and a software vendor should clearly describe the rights and responsibilities of the parties to the contract. The contract should be in writing with sufficient detail to provide assurances for performance, source code accessibility, software and data security, and other important issues. Software licenses. Software license is a license that grants permission to do things with the computer software. The usual goal is to authorize activities which are prohibited by default by copyright law, patent law, trademark law, and any other intellectual property right. The reason for the license essentially is that virtually all intellectual property laws were enacted to encourage disclosure of the intellectual property. Systems implementation. In this video, we are going to see about system implementation. Objective: to implement the new system, that is, put it into production. Activities. The activities involved in system implementation are as follows: conversion of data to the new system files, training of end users, completion of user documentation, system changeover, evaluation of the system at regular intervals, document or deliverable, a full functional or documented system in its operational environment. The process of ensuring that the information system is operational and then allowing users to take over its operation for use and evaluation is called systems implementation. Implementation includes all those activities that take place to convert from the old system to the new. The new system may be totally new, replacing an existing manual or automatic system, or it may be a major modification in an existing system. Activities during implementation stage. The activities involved in system implementation stage are as follows: equipment installation. The hardware required to support the new system is selected prior to the implementation phase. The necessary hardware should be ordered in time to allow for installation and testing of equipment during the implementation phase. An installation checklist should be developed at this time with operating advice from the vendor and system development team. In those installations where people are experienced in the installation of the same or similar equipment, adequate time should be scheduled to allow completion of the following activities: site preparation. An appropriate location must be found to provide an operating environment for the equipment that will meet the vendor's temperature, humidity, and dust control specifications. Installation of new hardware or software. The equipment must be physically installed by the manufacturer, connected to the power source, and wired to communication lines if required. If the new system interfaces with the other systems or is distributed across multiple software platforms, some final commissioning tests of production environment may be desirable to prove end-to-end connectivity. Training personnel. A system can succeed or fail depending on the way it is operated and used. Therefore, the quality of training received by the personnel involved with the system in various capacities helps or hinders the successful implementation of information system. Thus, training is a major component of systems implementation. When a new system is acquired, which often involves new hardware and software, both users and computer professionals generally need some type of training. Often, this is imparted through classes, which are organized by vendor, and through hands-on learning techniques. System implementation conversion strategies. Conversion or changeover is the process of changing from the old system, that is manual system, to the new system. It requires careful planning to establish the basic approach to be used in the actual changeover. The following are the 4 conversion methods: parallel system, direct cutover, pilot approach, phase-in method. Post-implementation review. In this video, we are going to see about post-implementation review. After a system is put into operation, it is necessary to periodically review the system to measure the system performance against predefined requirements. For this, post-implementation reviews are held. Post-implementation reviews are conducted to determine how well a system performs against the performance specifications. It may give rise to the decision to undertake minor or major changes to the system, or even to start work on a system and/or terminate the use of the system. The first post-implementation review is usually conducted soon after the system has been implemented. This is also called the post-installation review. The subsequent review is conducted after the system has remained in operation for some time. Reviews are then repeated periodically. The decision to review may also be prompted when the project rises in prominence because of reasons like some major problem is encountered, someone puts forth a proposal for the new system, management finds that the system is not being used fully and benefits do not seem to be forthcoming. Typically, the review criteria are set up clearly and include review against performance specifications, review of training effectiveness, review of operating costs, review of benefits, review against user objectives. Inputs to the review include the various data which is to be analyzed like cost data operations, data on benefits or savings, problem logs, bug resolution records, customer complaints or requests, change requests, comments or correspondence. System maintenance. In this video, we are going to see about system maintenance. Systems maintenance or support is a process of fixing errors and adapting the system to the changing requirements. In a well-designed system, the systems analyst has considered ease of maintenance and, to a certain extent, designed the system to adapt to the changing needs of the business. The system maintenance process is comprised of 5 steps. Define and validate the problems. Benchmark the programs and applications. Understand the application and its programs. Edit and test the programs. Update documentation. Define and validate the problems. Before a system maintenance project is started, it is essential that the exact nature of the problem be clearly identified. Errors reported by users of the system can be caused by real bugs, user misuse of the system, or errors in the documentation. The most difficult bugs to identify are intermittent errors. Intermittent errors are hard to replicate and can be caused by software faults, hardware errors, or user errors. At this stage, it is important not to jump to conclusions and solve the wrong problem. Benchmark the programs and applications. Before making changes, the system should be tested to establish a benchmark. This is particularly important for measuring the performance of the system. A simple way to benchmark is to rerun the test cases, adding new cases where necessary. Without establishing a benchmark, it is difficult to determine the effect of the fixes. Establishing benchmarks is particularly important for online systems that may be sensitive to the timing of events. Understand the application and its programs. The process specifications and DFDs in the project repositories are the primary sources of information, as are the actual computer programs. If there is inadequate information in the project repositories, try to use any available software tools to aid in maintenance. A number of such tools are not restricted to the mainframe environment. For example, Access provides a tool called Documenter, which can be used to document all the objects in an Access database. The output from Documenter includes the properties, relationships, code, and user permission of all the objects. With this output, should be able to understand the logic and structure of a poorly designed Access system. Edit and test the programs. After fully understand the corrective actions required, make changes to the appropriate programs. The most critical aspects of this activity is testing. Computer systems changing one aspect of a system often has totally unexpected repercussions on other parts of the system. You should rerun test cases after the changes are made and compare them to the established benchmarks to determine the impact of the changes, if any, on system performance. Update documentation. Documentation provides a record of the issues raised and what changes were made to the system. It provides an important source of information when planning future revisions or in the event that incompatibilities arise. System incompatibilities don't always appear in the most immediately revised version of the system. They may take several iterations to become evident, so having an audit trail of changes can be particularly useful. System safeguards. In this video, we are going to see about system safeguards. Security in a computerized system involves protecting all parts of the computer system. This includes the data, the software, and the hardware. Computer hardware and software are expensive resources, and they are usually a major investment in an organization. Data and its storage media is an expensive resource since it has been gathered with a lot of effort and is extremely valuable. Loss of data is a major loss to an organization. For example, penetrating sensitive data could result in breach of privacy and may be used to spy or a business rival. Ability to manipulate data by unauthorized persons could mean fraudulent transactions like transfer funds to divert money illegally to some account, delete records like deleting the police record of a criminal. Computer systems need protection from intentional as well as unintentional damage and misuse. Protection of data, hardware and software relates to the means by which we are able to prevent disruption to smooth working of the system. We also need to protect the data and software from being pirated and used illegally by others. Computer security refers to the techniques developed to protect single computer and network-linked computer systems from accidental or intentional harm. Such harm includes destruction of computer hardware and software, physical loss of data, deliberate invasion of databases by unauthorized individuals. Loss could be of many types. Some scenarios are the computer is not available for use, so some processing which is critical is held up. The software malfunctions and produces wrong results. The hacked system. There are many sources of threats to system security. They are as follows: errors and omissions, deliberate mischief or fraud by disgruntled employees, hackers looking at the system as a challenge to their technical skills, white-collar criminals, spies, theft, fire, natural disasters like earthquakes, floods, tornadoes, lightning, war and terrorist attacks, natural disaster threat. The types of security threats. Some scenarios of threats to computer system are as follows. The system could succumb to fires or earthquakes or floods, damaging our equipment and making it impossible for the organization to function normally. Data in the system could be tampered with. For example, in a banking system, an account holder, bank employee may transfer amounts from dead accounts into personal account and withdraw it. Confidential data may become available to unauthorized persons. Software may get stolen and used by competitors. The password security threat.